If I am streaming. Yeah, it looks like I am. All right. So I'm going to start a little bit early. If you're not here yet, you won't see this, I guess. But this will be on YouTube, and I'm just starting a little early to just explain a little bit about where I am, both in my streaming journey and also, more importantly, what code I've written since last week. So I've been starting to take my streaming journey a little bit more seriously. So I pulled up my laptop and I'm using this to check out the chat instead of having to take up real estate on my main coding screen. I can kind of just see where people are at. If people have questions, just by like glancing down to the chat. So I'm pretty proud of that. I'm pretty new to streaming, and I've seen like crazy setups with multiple monitors and like on a Mac. I know you can quick switch between them. I've used the Mac for a while before Windows, so there were a lot of setups with that and hotkeys and like multiple mics and streaming to multiple platforms and streaming through cloud platforms and like multiple computers. How to do like panel recordings, like this, all this stuff has looked awesome and made me want to go out and like go on a computer hardware shopping spree. But it's kind of intimidating. So you probably saw some of my previous streams. If you haven't, check out my YouTube channel. I've put them all on there. But yeah, you've probably seen my previous streams, and I did a pretty basic setup. And I'm kind of just doing like little step-by-step improvements as I go. So, it's kind of how I roll. You've probably seen it in how I program too. So, yeah, another shameless plug. I mentioned my YouTube channel. If you check out my channel, basically just check out my just search for me, Aaron Schlesinger, on my on YouTube, and you should find my channel. And I basically have the last 4 streams. So I've done 4 streams to date. So I've put them all on YouTube, and I'm going to continue doing that. So the first 3 you can see with the Athens logo. That was just random Athens coding and doing issue reviews. And last week I started the Crystal programming language. I don't like saying Crystal because I think it's so new that people probably don't know what I'm talking about yet. Hopefully that'll change and it'll get popular, more popular. So yeah, last week, we'll get into the coding now. Last week I started with the Crystal programming language. And I'll just like go back over that real quick. So my read on Crystal is that it's a Ruby-like syntax that's got a lot of the cool features of a compiled language. So that means it compiles down to machine code, not bytecode. So there's no VM that's running alongside Crystal when your code is running. Down to machine code. It's got concurrency. It doesn't yet have multi-core. That's in progress. But it's got concurrency primitives. And in the background, it can do I/O without blocking. It's got primitives for concurrency that are almost exactly like Go, but a little bit better, in my opinion. So it's got fibers, which is like a Go routine, or a green thread if you're in the Python world. And it has channels to communicate data and signals between those fibers. That's pretty cool. It also has generics, which something Go doesn't have. And generics give you a lot of flexibility to write your code once and then reuse it for multiple types. And it also is object oriented. So everything is an object in Crystal. You can define methods on objects. You can define methods on classes to be specific and more precise. You can override them. You can inherit from them. All that good stuff. And let me just go to the docs here. So you go to crystal-lang.org, click on docs. This language reference is pretty good for a young language. So, I mean, every programming language, almost every programming language, at least a modern programming language, has kind of like a guide. And it's not API docs, but it goes through the basics of the language. And then, like here, you can see it references out to API docs. So this will go to the standard library docs. Standard library is pretty good. And I found that I can start understanding how to write code and also understanding these API docs within like a weekend. So like maybe one full day, one like 5 hour, total 5 hours probably of like real work on the language, to figure out like how to read this stuff and how to write code. Because for me, writing the code is easier than reading the code and understanding the code. Just like if you're learning a spoken language, understanding it comes first and actually speaking it clearly comes second. So yeah, going through this reference, like all references, it starts out kind of slow. Like this is how you write a comment. Uh, it's pretty basic, but you get the idea. And then you go down to literals. It has a surprisingly small number of literals, which is nice. So this is like literals is kind of like basic types. All of these are objects, by the way, which is nice. So they all have methods defined against them. My favorite one is proc. Proc is basically a closure, or you can call it an anonymous function. But to be more specific, you can close over procs, which means they can take in the environment and the variables specifically outside of the proc that we're in. Let's say if a function returns a proc, it can capture the variables that were in that function. Actually, I've never looked at what a command is. Oh, you could actually run a command on the machine. That's cool. Anyway, that was an aside, I guess. It goes down, and there are more things with if else than I've really ever seen in a language that's this clear. So you can do some cool stuff. Let me go down and find one. Well, there's if else, of course, as an expression. This is it. So you can do a equals a value if it's something, if one condition, otherwise another condition. Going down, you can also do, it's not in here, but you can do like a equals something if it's one condition, else if it's something else, if it's another condition, else if, all the way down. So that's pretty cool, because otherwise you would have to do a lot more coding. So like something like a equals nil, and then you would have to do if blah a equals 1, else blah a equals 2. And that's more lines of code, and it's harder to read. So this is pretty cool. Keep going down, different kinds of while loops. It's got a pretty decent way to compose different files together in your program. You can do require. I talked about this. Everything is an object. There is a module system, both for modules in your repo and for modules for third-party dependencies. The third-party ones is called shards. And I just learned about this database called shardbox.org. And this has some of the more popular shards on the front page, as you can see with this title. There are some categories, but you can see there are a lot of shards that are uncategorized. It can keep track of dependencies, which is nice. And that's because there is a standard shard file. And if you're from like the Node ecosystem, you might recognize this, even though it's in YAML. So it's more than the dependencies. It's also ideas about like what should be run, who are the authors, what's the version. So it's kind of like a manifest. So it's got that going for it. This thing can read the shards files of everything. New stuff. You can depend on stuff for development, not production. So that's like test stuff. New stuff. And yeah, it's kind of a cool way to discover stuff if you're new. I haven't really dived into like stats or categories or anything like that. But I was talking to the creator of the site, and they're very passionate about Crystal. I think that this site will be around for a while and it will definitely grow. So if you're getting into Crystal, check this out. This is a cool resource to sort of make sure you're not reinventing the wheel. So keep going. My favorite feature is generics. This is an incomplete document, I think. So I'm going to go and try to update the doc. I've never clicked on this button, so I'll do that later. But some point I'm going to try to update the doc because it shows you how to parameterize or make generic a class, like right here. But you can also genericize or make generic functions. And I'm going to show that in my code. And I don't see that here, and I've looked elsewhere in this guide, and I don't see it anywhere else. So I discovered it in other people's code, and that seems to be a thing you can do. And I've tested and it actually works, so that's cool. Really awesome closure support, both for how you deal with them in your functions and then how you call them in other functions. It's got this cool thing called yield. So if you've got a function that has a yield in it, you can call it and then do function name and then do, and then on the next line indented, you put your code that should be run as the callback, basically callback. So twice calls yield twice, so it runs, this is the callback, it runs that twice. I really enjoy that. I think that's super cool. And you can also do this thing called blocks. In this example, the block example is exactly the same as the yield example. But you can do a lot more cool stuff with blocks. And it goes on and on. There are a lot of different ways to do callbacks, basically. It's not exactly callbacks, but you get the idea. It's kind of the same thing. Lots of different syntaxes. Each one fits your programming style. I actually went from the more Go-y syntax to more of the Crystal / Ruby syntax. So I really enjoy, how this whole callback, block, closure, whatever, anonymous function, whatever you want to call it. I enjoy how this feels when I'm writing it. You can do type aliases, pretty cool. It has exceptions, and I actually, in my code that I swear I'll get to soon, I am using a combination of exceptions and not exceptions. I'll show you what I mean by that in a second. Exceptions is pretty handy. The compiler will actually help you with catching, or they call it rescuing exceptions, so that's nice. I've never looked at this. Type grammar. I'll have to look at this. I have no idea what this is. I know you can do unions and stuff like that. This one I should point out. The question mark. So this is a type alias, but you can put a question mark after pretty much any value. And that can say variable equals blah question mark. That means variable can be either the blah or nil. So this is really handy if you're like looking something up in a map, a hash map. You can say my last name equals hash map bracket Aaron question mark after the bracket, and then my last name will either be my last name as a string or nil if I didn't exist in the hash map. Just with the question mark, that's super handy because otherwise in other languages you would have to say, is Aaron in the hash map? If yes, then the last name equals Schlesinger. If no, then the last name equals nil. So this saves you like the if, the value, the else, the other value, and then the close bracket. This saves you like between 4 and 5 lines depending on the language. So I'm super into that. I really like this question mark syntax. And I took that, humble brag, I took that sort of to the next level in the code that I wrote. Macros, I haven't gotten into macros much, but I like that they're there. Feel like I'm going to be able to abuse those pretty well. It talks a little bit about the standard library. It talks about its database stuff. These guides are pretty cool. I haven't looked at performance, but I have looked at concurrency. And really all the guides, I also looked at testing. So really all the guides are written in like real friendly English, and not really like dry, terse stuff. So these are less of a reference and more of, like it says, a guide, with great examples, just kind of like a joy to read. So if you're not understanding Crystal, I kind of suggest reading these, even though you might not really get everything they're talking about, especially the syntax. It's kind of nice to just read about read about the sort of mantra, or just sort of like how things look, and getting just familiar with like what does the type character mean, stuff like that. So yeah, I mean, this is a good place to start. After you're into this, go back to the intro and click API docs. This is how big the standard library is. So it's kind of cool to see this. Like, I don't even know how old Crystal is, but I know that for other languages that have been around for a while, they don't have all this stuff. Like some languages I know have JSON support, but they might not have logging support that's as rich as Crystal's is. They might not have like zip file reading or YAML reading built into the standard library. So there's just like a lot of stuff in here, and that's kind of like crazy. Like, it's intimidating, but at the same time, just for me, like macros, like I was talking about, I don't know about all the stuff in here. Things look shiny. Like, what is box? I have no idea. But, things look shiny, and I can certainly get distracted and nerd sniped. But at the same time, it's nice to know, like, hey, at least it's there. So anyway, without further ado, let me go back to my code. Okay, so last time, let's go over to where we left off last time. Commits. Going back down here, 8 days ago. Let's see. I think I left off, April 3rd. So this was the last commit that I was at. So I got rid of write documentation for cprocs. That's funny. I'll get back to that because I think I actually did write some. This code under post was broken. And it was because I couldn't figure out why URL code, basically why this line was not compiling. The reason was URL code was a string, so that's all good. But URL was not a string. So looking up here, I was looking up the URL in JSON, and then that's that question mark. So this was saying, get the URL out of JSON, and if it's not there, return nil. However, the URL out of JSON doesn't come back as a string. It comes back as any type that can be in JSON. So I sort of kind of showed that Crystal has union types. And maybe I can find that. I'm not going to be able to find it fast enough. But what this means here is the URL will come back as either a JSON string or a JSON number or a JSON object or dictionary, JSON array, nil. I think there's like 5 or 6 other JSON types. And actually, if we go in here, going over to the API docs, if I go search for JSON, we go in here. If I click on any is a convenient wrapper around all possible JSON types, which is this. So this is what it looks like. So this pipe is the union operator. So this means if I have a JSON : any as a variable, it could be any of these types. So I have to check to make sure if I want it to be a string, I have to check to make sure it is a string. And then I have to do like an else. And if it's not a string inside the else, then I have to do something else. Hence the name else. Oh, I'm my own greatest fan, you guys. So let me go back to GitHub. I'll close this up. So yeah, this was the problem. URL was coming back, even ignoring the question mark. URL was coming back as like a string or a nil or an integer or whatever. So when I was trying to do this down here, this was expecting that, well, this operation is actually defined in the web library I was using called Kamal. And so when I do this equals, it requires a string, but I was passing, again, a nil, an array, a hash map, or a string, or an int, or whatever. So that wasn't going to fly. But I just didn't really understand enough about the language to be able to parse the compiler error. Now, looking back, in hindsight, I feel like the compiler error was actually pretty good. But I'm kind of biased now because I figured out what was going on. So yeah, I'm not sure what I did wrong, or I'm not sure what I exactly didn't understand in order to not be able to figure out the compiler error. But I got there. And the key thing was, if I went into the compiler, I basically saw expected a string, but got this big, huge line of stuff with pipes in between it. And that was super intimidating at first. But I kind of zoomed in and was like, well, what's up with all these pipes? That's when I discovered those JSON API docs. That's when I saw the pipes in that JSON any. And that's when stuff started to click, and I was just like, hey, maybe that's kind of pointing at what the problem is. So now on to the solution. So let's go to cprox. The code now is totally different. So I went off the deep end. What I did was, instead of dealing with this massive union type of nil, integer, whatever, I keep saying the whole thing, nil, integer, string, array, hash map, I created this thing called a result. So before I go into result, I'm a big fan of functional programming. So before you turn off your ears because you heard functional programming, I would like to explain what I mean by functional programming. So to me, functional programming means I don't have to do as much exception handling, and I don't need to check for as many different types. So you'll see in here, I am doing this big, long, intimidating thing, but I am also not checking types. I'm not checking to see, hey, was it a string, or was it an array, or was it this, or was it that? So yes, this looks intimidating, but at the same time, I can kind of follow it step by step. So basically what I'm creating here is a pipeline. So every time you see an open brace curly and a closed curly, that is a step in the pipeline. Okay. So before I go into the result, actual code to implement it, I want to explain what's going on. Okay. So I'm taking in a body IO, and the body IO is the body of the post body of the request. And this web library I'm using called Kamal, it gives it back to you as an IO or nil. So obviously, if the post had no body in it, it comes back as nil. Otherwise, it comes back as an IO. So I looked up the IO docs in the API standard library. It's got this nifty little function, get s to end. Basically, that just converts the IO, excuse me, to a string. So fair enough. This actually probably will have an error. I forgot about this. If it's nil. So I got to go and handle that later. But anyway, in this post body, if you call it right, it should have some JSON in it. So I'm getting the JSON here as a raw string. Okay, so what I did here was, that's the first step in the pipeline. But the thing is, oh, actually I do handle it. Sorry. The thing is, when I pass in the body IO, the result is saying, okay, I'm going to store one of two values. I'm either going to store the IO or I'm going to store nil. And then when I do this first stage of the pipeline, it's either going to call this if it's the IO or it's not if it's a nil. So it's just going to skip this step in the pipeline. And it's just going to keep being nil. And then it's going to go to the next step of the pipeline. And then it's going to do the same thing. It's going to say, okay, if the value was an IO, it's going to take the return value from the previous pipeline step and pass it into the second one. But if it's nil, it's just going to keep not running it. So actually, if the body was nil, it's not going to run any of this highlighted code at all. So it's just going to be nil till the very end. Okay. So going down here, let's assume it was an IO because that's the happy path. We get the string. Next step, we pass in the string here. Oh, it passes it into us. We parse it as JSON. And then we get back this any. So parser.parse, let me go back to the API docs. Go back to JSON and into parser. So I created this parser.new here, and that is this. So you can see it takes in a string or an IO. So that's great because I know val is a string. And actually, now that I'm looking at it, I could have skipped this. But anyway, let's just write a little to-do. Pipeline step, because JSON parser new can take in a IO or a string, and env.request.body returns an IO. All right, so yeah, I could skip this. But anyway, going back down to here, I create my new parser, and then I call parse. So check it out, parse returns an any. So going back to any, remember, an any is this, blah, big old thing. So now when I call parser.parse, I'm calling that and it's giving me a val in the next pipeline step. Now this pipeline step is called flat map instead of map. So you notice the maps I'm calling here, the flat maps I'm calling later. I'll get into what the difference is, but for now this is just another pipeline step. So now I know that the parser can return all these different kinds of things, all of this. For this step, I'm going to say, okay, is it nil? So did it return this one right here? And if it did, I'm returning an error. This is not an exception though. It's just a value called error. And it's returning an error that has a JSON not found error value in it. Now, confusingly, JSON not found is an exception type. But this is different. I'm not throwing it. I'm just using it as a variable. Okay, otherwise, return the value. So now at this point, if I'm in the else, the value is everything but the nil. So it's all this stuff right there. Okay, so this means that if I go into this if, the pipeline stops. Otherwise, I go into this if, then the pipeline continues. So let's just assume it wasn't nil, pipeline continues. So we're going to stick with the happy path. So next up, I'm doing another pipeline step. We get in the val. The val is any number of these any one of these types. And then we say, okay, let's try to cast it to a string. If we cast it to a string, but it wasn't a string, we're going to throw. We're going to throw an exception. This is a standard library function. I think it's a built-in function actually, but either way, it'll throw some exception that I didn't look up. But it'll throw, and then we're rescuing it. This is like catch. We're catching the exception, and in that case, we're returning another error. This time we're saying the error is JSON not string. So, and I'm getting into the crystal syntax, which is also Ruby-like I mentioned. And you don't have to put parentheses out of function or in function calls. So a little less typing. I'm doing a space instead of 2 parentheses. I'm lazy. I like it. All right. So now we're done. See, we're done with this whole variable. So yes, it's kind of like confusing, I guess, if you're looking at it for the first time. But for me, my mind kind of follows it better because I'm just dealing with functions, not ifs, and not too many exceptions. And I'm actually going to get rid of this pipeline step in a second. I think that'll work. So now we're going into this other pipeline. Now this pipeline is simpler. This one, we're taking out the URL code from the URL path. So this. So this one is just a hash map. And this is a hash map, or this right here is a hash map that goes from string to string. So keys are strings, values are strings. Okay. So I'm trying to get the code out, which is this. And the code out right here, the highlighted part without the question mark, that's going to return a string. I think it'll return an empty string if it's nil, maybe? I can't remember. But I'm adding the question mark to explicitly say, if there was no code, then it's nil. Return nil. Then I'm shoving that into a result. Okay? So the result is saying, all right, I'm going to take in a string or a nil type. And then I'm going to do another pipeline stage. This pipeline stage is going to return the string, but if it was a nil, then throw an exception. Okay? And this is the exception. Code not found in URL. Okay? So now I'm kind of combining the functional style and the exception style. We saw that a little bit up here too. Okay. And then down at the bottom, I'm saying put it in the database. So really this, if I really wanted to be explicit about the error, about the return type, I'm going to call it a string. The same thing up here, I've called it a string. Okay. So after all that, now this was all in a begin block. So that's the block that can throw exceptions. And we saw that here. So down here, we're catching the exception. And then if we got one of those exceptions, so either one of these has a status code and a message, a string. So I had to fix that there. So if we get to here in the begin block, that means we're good. We wrote it into the database, we're all good. And it means we wrote the URL code, the shortened URL and the actual URL lookup into the lookup table database. So blah, blah, blah. It's funny that this is the actual functionally good part of the code. And this is the rest of it to do the setup and the error checking and everything. I tried it out, and all this error checking stuff would actually be longer if I had to do a bunch of ifs. So for what it's worth. So error case, if it's an exception we know, we're going to bail with that exception's code and message. Otherwise, we're just going to do a 500 server error because we don't know what happened. Okay, so oddly enough, oh, seashell. Oh, my ZSH is updated. Whoops. Let me go into here. There it is. So I'm going to run it. And it has a compile error. I didn't see this yesterday. That's funny. So let's actually go through and try to figure out what's going on. first thing I'm going to do, I'm going to check it out. Actually, I am going to combine this pipeline step and this pipeline step. Ooh. Okay. So basically, I'm going to do this. Since this is checking to see if it's a string, but this is checking to see if it's nil, I'm going to just put it in one place. Okay. So basically what this is doing is now I'm saying, give me it as a string. I'm going to just say JSON, not a string. I will notice here, I'm saying, I'm checking to see if it was there or not. Basically, I'm just going to not do that anymore. Okay. But actually, maybe I can do this. So yeah, we're putting a few more ifs in, but hey, we're doing one less pipeline step. I'm not too broken up about it. And that's the thing about functional programming, by the way. Some people, I think, make it out to be like it's, you know, this religion and you should never do if else. And I hear that sometimes. But honestly, it's still sort of a use the best tool for the job type of situation, just to be completely honest with you. So don't worry about it too much if you're just getting into this stuff and you need to fall back on an if else. Because I've been doing some functional stuff on and off for like 7 years or something. And honestly, this just seems easier to me, just to be completely honest with you. So I'm just rolling with it. So it's okay to be not super religiously functional, especially if this makes more sense to you and it's less code and you're pretty sure that it'll make more sense to someone else too. So I could probably go and comment this too, which maybe I'll do offline. But even as it is, like the crystal syntax is like fairly clear. If it's nil, question mark, is it nil? Then we're going to return an error. Otherwise, let's try some stuff out and see what's, let's try some stuff out and see if we can convert it to a string if it wasn't nil. Alrighty. What happens now? I bet we're going to get the same compile error. Yes. So cool thing about Crystal is they try to give you the lowest stack frame that failed, but you can also get an error trace. So I'm gonna do the error trace here. Let me actually clear the screen. Okay. So if we go up to here, the real actual code is the body io.map. Okay. So it's instantiating a result for IO and nil, and then we're calling map on it. And then inside of the result code on line 55, it's trying to see there are no overload matches for proc IO and string.call with type IO and nil, IO or nil. All right, so line 55, going down here. So let's see here. This is returning a string. So it's saying that the block we're passing is taking in an IO and returning a string, but it's expecting the proc to be IO or nil. Okay. So for background, this is the syntax to do generics on a function. Okay, a function and not on the class. So the class itself, right here, it does have class level generics. So you can see here, like when I did the result.new, and actually just a quick aside, when you do .new, then Crystal automatically calls this initialize function. Okay. So like this right here just corresponds to this. Okay. So when I call initialize, it's taking in the value, and this value with the @ sign automatically gets assigned to, it's a class level variable. Sorry, it's an object variable. So it's available everywhere else. And it's a T or a U. So those are the generic types. And it comes in and we see here it's an IO or a nil. So that is this right here. So going back down to map, it's taking in a, excuse me, it's taking in a block, and the block is a function that goes from IO to a new thing. Okay. So we're doing block.call, and block.call is taking in, this should be taking in a T, which would be an IO. So the proc, no overload matches proc IO string call with type IO nil. So let's see what's happening here. I'm going to make sure that the value actually is a T, which is an IO. Okay, so this should, right here, it should compile error if, if it should compile error if it's not an IO. Yeah, so let's see. Let me clear again. There we go, clear, and there we go. Oh. So I think the problem is that when we passed in the body IO, the T was actually IO or nil, and the U was nil. So that is weird, but that's the problem. So we're going to do body IO equals env.request.body if env, let me shorten this. Body equals env.request.body, and then body IO equals body as IO if body is a IO, else nil. And let's see, maybe that's not the right thing. I wonder if this is going to fix anything actually. That's right, because as is going to throw. So maybe this is not the right thing. Body IO equals env request body. Body. Let's try this then. We're going to make sure the result is the right type. And then we're just going to do res dot map. IO nil, that's the type, and then equals the value. Undefined constant body, IO and nil. Man, my typing skills and my thinking skills are tough to do at the same time. Alrighty. To call with T, type must be IO, not IO or nil. So that is in, that is in line 55 again. 55. So is a U. Oh, so I might have to cast it. So val as T. Maybe that. Because I know that the nil question mark, so if we do like if something dot nil, then in here something is nil, and then otherwise something equals its actual I'll type it out, its actual value. So that's like a crystal built-in thing, but I think in this case we don't get that automatic like nice stuff. We don't get the automatic crystal compile time guaranteed casting. So this is kind of, I think if this works, this is kind of another property of functional programming. Unless you're in like a crazy futuristic like Haskell functional programming language that was designed to only do functional stuff and force it on you. If you are writing functional libraries, you're going to have to do some stuff like this that feels weird, basically. So let's see if this works though, before we go and start gloating. Okay. Initialize val t result.cr5. And then we were calling line 5 on line 57. And then we were getting into that code in cprocs line 54. So let's start there. Got into it there, and then we called into line 57. Okay, and then that, where'd that go to? Line 5. Okay. This might work. So what we were doing here is we're saying, okay, initialize only takes in a t, but OK has a t and a u, and initialize returns a result t and u. So if the compiler is trying to figure out what u is based just on inferring what this type is, it has no idea. So I think that I have to do a for all u. So by the way, for all is, as far as I can tell, is not documented yet in that crystal, that guide that I was showing. So I'm kind of going off of like other people's code and what I think it, to be honest with you, what I think it should be. So let's see if this works. I think this might help because I think it's saying, okay, u can be anything. But let's see. Undefined constant u. Okay, that's not it. So I am going to shortcut here because OK and error are really just shortcuts for saying basically just saying like result new for the success one and result new for the fail one. So I'm going to delete these, and going down, I call OK.new here. I'm going to just do result.new val or nil. Actually, I think I have to do that because result needs to know the two different types. Let's see if that worked. Def map result line 39. I love debugging. For all v. Oh, interesting. Must return string or nil, but it's returning either IO or nil or string. So that's weird. What have I done here? Map, block from T to V. Okay. So if it's in this case, it's going to return an IO or nil because that's self. Otherwise, I'm trying to call this thing and I'm trying to make it into a string in this first case. Trying to make it into a string, so that means it's going to return a string or a nil. So I have no idea how to fix that. So I was all high and mighty about functional programming, but I have no idea what I'm doing now. Let's see. So I was thinking about this. I have to return the same type in both cases. And what that means is, how do I get this to be a V? I think maybe I could do this. Result V U. Because it's a nil anyway, so I should be able to cast it to a different success value, a string or nil instead of an IO or nil, because it's already nil. So I think that might work. Let's see. Oh boy. We got to scroll for this one. String, string. Must return cproc result string nil, but it's returning result string nil or result string string. All right. So let's just make sure both are a result VU. So that should be string or nil. This is like type level debugging, not runtime debugging, which always makes me crazy. But anyway, I digress. So ret, oh boy. I'll do the same thing here. Ret equals result, ret of result. VU equals block equals result dot new val. All right, line 46. Ret is already declared. Where is it already declared? Oh, maybe it's not smart enough to know about this. Maybe it's not smart enough to know that these are different blocks. I'm not really sure. Type must be a string nil, not a string string. Okay, so for some reason, this is returning a string string. So we should look up what this is. Get s to end. Yeah. So we're gonna go and figure out what get s to end. Let's just search get s to end. That's on IO. It's supposed to return a string. Okay. Okay, so that would be a T. Block.call to call with. And the block should be returning a string. Something's up with this block. So new val is a VU. New val. Interesting. So instead of sitting here watching me think, let's do this a little bit different. Let's take some functional stuff out. All right. So we're going to do if, let's actually shorten this. Let's write this the imperative non-functional way. So if env request body dot nil, we're going to do halt this. Oops, we're going to do halt env blah 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 this. And then status code is 400. because it's a client problem, and then no post body. And then else, that means that the request body was there. And then we're going to do else if. We're also going to check for the nil, what do you call it? Code in the URL. That's another 400. Okay. So now we know that we have a request body and we have a code in the URL path. So, and let's pull some of these out. So maybe code equals env.params.url code, and then maybe post body equals env.request.body. Yeah, okay, so maybe post body.nil, and we're gonna do maybe code.nil. And I did this because now I can go in here and say maybe code because Crystal will guarantee, if I call nil up here, it will guarantee that maybe code in the else is not nil. Same thing with this if. If I call maybe post body nil here, will guarantee that maybe post body is the IO in here. Post body equals maybe post body. All right, so now I know that code is a string, maybe post body is an IO, and now we can get to our JSON parsing. So I'm just gonna go and start deleting stuff. So you can kind of see here, like I am totally not being a functional programming zealot at all. I'm just ditching stuff. So now we've got our JSON parser, and we're gonna get our JSON any back. And then we're gonna do if JSON any.nil. And we're going to do halt env. What is the thing again? Status code 400 response no JSON body. Else. So now our JSON any is not nil. Else if. Actually, let's just do our else. Begin and then this. JSON string equals JSON any.as string. And then we're going to do our JSON stir. And that now is the actual URL. Wait. JSON any as. Actually, this is going to be a hash map. I think it's a hash map. JSON. We're going to go into our parser and parse returns an any. Any is in any type. That is a hash of string to JSON any. Okay. And then it's a hash string to JSON any. Okay. Now we've got our JSON hash. URL any equals JSON hash URL. Maybe, yeah, let's just URL any. If URL any dot nil. Halt again. All right, so now URL is an any. So URL and then begin URL equals URL any dot as string. Now we can do our db URL code equals URL. What did I call it? I'm actually going to just call it code and post body. Because although it is a maybe, I am going to be guaranteed that the code is the code. Yeah, I don't need that. So I'm going to be guaranteed now in here that code is not nil, and I'm going to be using that down here. I'm going to be guaranteed that code is not nil and post body is not nil, which I use there. So it's kind of like saying post body. If I say maybe post body down here, it's not really a maybe. So I just kind of gotta, since I'm using it more here and this is like the success path, I kind of gotta name it weird here so that I can use it and feel like it's normal here. Hope that makes sense. All right, so rescue typos. So rescue, in this case, this could throw, so I'm going to do halt env status code 400 response URL was not a string. Okay, and then end that, and then end that. Let me close that down real quick. And now we've got our other one here. This can throw, so rescue. And then this one is going to be, it wasn't a hash map. So halt env status code 400 response. JSON was not a hash. I think it's called object in JSON terminology. So end that. Now end that. And now end that. That's the top level one. And we can get rid of these because we're not doing that stuff anymore. And we're going to go down all the way here and unindent one. This stuff we don't need anymore because that's all the functional goodness that we deleted. Then see, so it's more code for sure. We're not using this functional stuff at all because I don't want to try and debug it in front of all you and just sit here with my mouth open like this, trying to figure out what the compiler is telling me. But this should be working. And I will commit this. Let me see if it compiles first before I claim victory. Can't cast JSON any to string JSON any. Why not? Interesting. So, as you can see, I still haven't gotten the hang of this quite yet. Let's see, JSON parse. That returns an any. Oh, maybe I can just do that. I can do parse, and then I can do, let's see. What would it be? We can do URL equals JSON any URL, and then do our question mark again. If URL nil, halt env status code 400 response no URL in JSON body else. And now we're going to do our, we can skip down to here, begin that. That's nice. We kind of shortened it a little bit. And the else, and we don't have this anymore. That's nice and clever. I like that. Let's see if that compiles. Blah. Undefined as string. Oh, I used the old one. Just URL. Can't cast any to string. Oh, we have to do as s. The JSON any has a built-in functions to convert to all of its possible types. As array maybe, as bool, yeah. So as s. Hey, it compiles. All right. So yeah, I'm way over my hour. As you probably saw there, I have a meeting with my boss as well. So I'm gonna leave it at that. I'll check this code in. And next week we're going to come back and we'll actually try it out. And I have some more ideas for improvements as well, or more features. And also I have some ideas for tests. And also, if I get some time, I'm going to try to figure out what was up with that functional stuff. And I feel like if I take some of my learnings from this and the as s, I might be able to compress down that pipeline. And also at the same time, I'm hoping I'll be able to figure out what the heck is going on with this map. And this flat map, I think probably is going to have the same exact problems. So tune in next week for more of my fumbling around. And we've got a working thing today. I'm really excited about that. At least it compiles, which has been a big headache for me for the whole week. And for a lot of this this live cast too. All right, all. So thank you so much for coming. I hope that you play around with Crystal, the language, a little bit. There's a lot in there, but so far it's relatively easy. Not only get started, but then to write code like this and start getting yourself in trouble pretty quick too, which I think is fun. And also be safe this weekend. Wash your hands a lot. Stay inside when you can, but also make sure to get some fresh air too, responsibly. All right, all. Talk to you next week. Same time, same place. Bye.